The Mars Phoenix lander is headed for the north polar region of Mars, and its goal will be to search for habitable regions, places where life may have existed in the past.
The phase that we're in now is called cruise,
which sounds really easy and laid back, although it's actually a very busy time for the spacecraft teams.
We're busy making sure the systems of the spacecraft are working as they should.
The teams are busily preparing for the science that's going to occur after landing.
And the navigation team is getting ready to make sure that the spacecraft actually gets to its target on Mars.
It's very similar to the sport of archery. In archery, you have the archer who's standing some distance away from the target, and that person's job is to make sure that the arrow hits the target.
An archer will have to draw back the bow with a certain amount of force. Secondly, the archer has to make sure that he aims the arrow at a certain angle, and then that arrow actually has to traverse the correct amount of distance so that it hits the target. These three things have to come together just right.
With launching a spacecraft to Mars, it's a little different. The bow in this case is a 250-ton rocket.
Our arrow is the Phoenix spacecraft.
It has to travel over 420 million miles to its target.
That's 70 miles long by 15 miles wide.
This is like trying to shoot your arrow from Dodger Stadium and hitting home plate at Wrigley Field in Chicago.
So this seems almost like an impossible shot to take just in one single shot. So we actually make it a little more fair by having 6 opportunities to correct that trajectory along the way. Imagine if you could shoot an arrow stop it in its path, check to make sure if it's on course for the target, and if not, be able to nudge it back to its target so that it's headed for the right place. Now, of course, our spacecraft is moving at about 60,000 miles per hour. It never stops. So the corrections have to be performed along the way while the spacecraft is still in motion.
We track the spacecraft using the Deep Space network of antennas, and we figure out exactly where the spacecraft is, where it's heading, and then compute where it actually needs to be. We develop commands to fire the thrusters on board the spacecraft to make any corrections that we need to make.
For approximately 5 minutes.
22 hours prior to entry, we have one last chance to make a fine-tuning of where we're going to land.
The arrow hitting a target is a decent analogy for what the navigation team does.
But in reality, it's a lot more complicated than that.
Earth and Mars are rotating around the sun at various speeds and constant motion.
The spacecraft itself is moving very fast across the solar system. It's trying to hit a moving target, and that target is also spinning on its axis. And we have to keep all of these things in mind while we're attempting to hit this target. It's pretty challenging, all these things that you have to take into account and actually get done during this so-called cruise phase, where it's not laid back at all by any means.